Hello and welcome to today's webinar in Knowledge Miles for the lectures associated with the 695th Lord Mayor of London. In this series we address connections in and around the square mile, what the current Lord Mayor Michael Magnelli calls the world's coffee house, and how these connections might help us tackle future global challenges. Today's lecture is Making the Future, the Opportunity in Digital Manufacturing, and is part of a series of lectures from those hidden gems of the City of London, the livery companies. In this case, we have the engineers on show, the worshipful company of engineers, 94th in the precedence order, who I think share premises with the Saddlers on Gutter Lane. My name's Richard Harvey. I'll be convening this session and moderating the Q&A. For those of you who are curious, I'm a professor of computer science at the University of East Anglia. I used to be a Gresham professor, hence the connection with the City of London. Bit of housekeeping. You should see the agenda slide up here. I'm not going to run through the timings, but we will try and keep to those. Without further ado, let me introduce the speaker for today's lecture, who is Dr. Lina Huertas, who is the Manufacturing Industrial Advisor for Microsoft UK. Lina trained as a mechanical engineer and, as you might expect, has a splendid curriculum vitae or resume that in normal circumstances I would spend tens of minutes enumerating for you. But these talks, we follow the sort of culture of the City of London, which is brevity, brevity, brevity. So if you want to find out more about Lina, then please click through on the Gresham Society's website, who Gresham Society co-sponsors these talks, and read about her background. So that is enough from me. Now it's time for the main event. Over to you, Lina.
Thank you very much, Richard, and afternoon, everyone. Pleasure to be here talking to you about the role of digital in engineering, and for me has featured right from the beginning of my career. Even though I'm a mechanical engineer, which is something very physical, there has always been a digital element, and it has been increasing. And today I want to tell you a little bit around some examples of the type of impact that it can have in societies overall. So if we move on to the first slide, please. There's an element that I want to talk about around the role that manufacturing plays in society, and sometimes is hard to see the global and the national context of manufacturing as it's not usually or not always appreciated. And there were two elements I wanted to talk about. On one side, there's the element of the responsibility that the manufacturing sector plays because of the impact that it has, and obviously has a huge impact in terms of emissions and energy consumption. It's a very prominent sector and a large sector. It has a huge impact on people, not just through the products it generates, but also through the employment it generates. And just in the UK, there's I think there's even these figures might be bigger today, but up until 2022, there was around 2.5 million direct jobs created by manufacturing, and indirectly up to 5 million. So it's a large population of people that are employed and whose prosperity depends on manufacturing. And if you look at the contribution to GDP, even though the numbers again, the direct numbers can be around 10%, which is still sizable. The indirect element of manufacturing and what manufacturing creates through supply chains and through other sectors linked to it are around 20% of the GDP. So as a sector, we have a huge responsibility when it comes to all the elements of sustainability, from environmental to societal to financial or economic. And alongside that responsibility, there's a huge opportunity for manufacturing, because not only the sector creates, yes, a lot of emission and energy consumption, but actually when you talk about the future of the world and how we want to transform the world, a lot of these changes that we want to achieve won't happen without manufacturing of electric vehicles, for example, electric infrastructure, hydrogen infrastructure, the future of healthcare, if you think about future equipment, future diagnostics, future prosthetics, for example. And there's if you look beyond even the topic of space exploration, depends on infrastructure and products that are created by the manufacturing sector. If you look at the people side of things, we already employ people that are paid on average 10% more than the whole society in the UK. And we have the ability to do even more for society, again, not just through products and things like sustainability and health, but also through employment, through wages that enable further prosperity, but also through skilling and growing the capability of the people employed in the sector. And one of the things that we see today is there's been a really healthy increase of the output of the manufacturing sector in the UK. And it has gone from 2022 to 2023. It has only 1 year, it has gone up around 20 or 22%, which is very significant. So manufacturing plays a really big role in the UK. And I just wanted to set that context before we go into the next topic, please. So that's from a UK perspective. When we look at it in the global stage, and if we can have a look at the first figures, manufacturing has, we've gone to a place where a lot of the manufacturing was concentrated in Britain. That has changed over the last decades, but we're starting to recover or have an even more prominent role in the world stage. So we've gone from last year to this year to the 8th largest manufacturing nation in the world. This is by overall output of value. But when you look at it per employee, actually, if you look at the next figure, please, you can see that the productivity of a country that sometimes in size could be quite small is quite staggering in Britain. And actually there has been this year the publication of some numbers that said that the growth of productivity per job in the manufacturing sectors has grown by 25% in 10 or 11 years. So we're really doing quite good in the, or quite a good job in the world, and we're increasing productivity through different means. And a reflection of the momentum behind the manufacturing sector has also been seen quite recently, just in the last couple of weeks, with the recognition by the government on the role that the manufacturing sector plays in the nation. And I see the momentum behind manufacturing growing even more because there's been a definite consideration of the sector as part of the whole national strategy, and a reflection of this has been the announcement of further 4.5 billion of government investment announced just last week or the week before, going into the manufacturing sector, of course into the areas that really matter to society when it comes to energy transition, sustainability, healthcare, and things that are really going to matter to transform the world into how we see it in the future. So that's just a little bit of context of the role of manufacturing in the UK and in the global stage. Now, I want to start talking a little bit more around what is possible when we talk about digital technologies in manufacturing. So when I talk about digital technologies, the kind of things that I think about are around cloud and computing, that are kind of parallel worlds, and the ability to process information, that information itself or the data. And they say, there's a very common saying that data is the new oil, and that's really, I think, is becoming more and more of a reality for organizations these days. And obviously, particularly in the last year or so, but even before that, AI has been gaining a lot of traction and demonstrated how it can help not just transform businesses, but help businesses have a leading edge in their in their own sectors. So this is what I mainly mean by when I talk about digital technologies, and the impact that these technologies can have is immense. And I want to focus on the topic of AI for this specific section, because it's the pinnacle of all of that underpinning foundation around computing and data. And if you look at what AI can generate in terms of economic output, only in supply chain management and manufacturing, traditional AI and analytics can unlock globally between 1.2 and $2 trillion of value. So it's really quite significant. And when you start looking at that in the context of what's possible when you put together all of the sectors and all of the types of AI, including generative AI, of which there has been much talk in the last 12 months or so, you can see that the kind of numbers we're talking about are immense in terms of potential. And I think we have, again, talking about that responsibility and opportunity to really exploit that economic potential. And there's an element of we need to be quick to unlock that economic potential so we can maximize it, but also there's an element of purpose and what are we using it for, and being intentional around the purpose that we want to achieve, because it's obviously the financial side of things that is always very present, but I think there's we all have a responsibility of thinking about the whole societal topic and the sustainability topic and the impact we're having on societies as a whole. So that in terms of just some numbers about what can be achieved. And apologies here, I kind of messed up my animation, but if we keep going with the first example, I'll just take you through 4 kind of different stages of I suppose the manufacturing value chain, and give you some examples that are closer to me. And of course there are so many more examples, but these are just a few examples of things that I see happening in the sector. And for example, something that has been really interesting in the area of material science specifically, the topic of computing and high performance computing has started to unlock huge amounts of innovation. And when you're talking about, for example, creating alternative materials, Johnson Matthey has worked a lot in their quantum teams with their quantum chemistry behind some of their products. They're looking towards the topic of sustainability and how can they start creating all of these technologies, like or enabling things like hydrogen fuel cells that can have a very significant impact in terms of sustainability much quicker than they traditionally could with previous technology. And by using, for example, in this case, high performance computing as well as quantum chemistry, they have been able to test different type of alloys and molecules in a much more compressed period of time. For example, here you can see that certain chemistry calculations have taken from 6 months to just a week using different technologies, and accelerating time to market for this material. If you think about the fact that you're now suddenly able to take a product to market 6 months before and start unlocking positive sustainability benefits 6 months before you would normally been able to, is quite impactful. Another example is Dow Chemicals. So very similar example, but different technologies. So again, they need to generate materials based on different customer specifications very regularly. And it's a process that takes quite a long time because you need to be able to leverage all of the knowledge from the scientific base, but also the internal organizational knowledge that has been generated by creating previous materials. And it takes quite a long time to find this knowledge and use that knowledge and interpret it for the benefit of creating a new material. And in this case, what they have done is use AI to be able to take all that knowledge that is usually in the way, well, It can be in the format of numbers, but it can also be in the format as just natural language and things that are in textbooks or in previous records that is traditionally very difficult to process. But they have used artificial intelligence to reduce some of those processes from months to seconds, and is from the point of view, for example, revenue for an organization and unlocking potential revenue in much shorter timescales has a huge impact. So this is just some examples of that first stage in manufacturing around the design and development of products and processes. When we go to the area of production, one of the things that I wanted to talk about is the topic of accessibility and empowered workforce. And of course, there are many more topics around this, more around the production side of things, and we'll discuss a little bit around that later. But I just wanted to show you a video. And before we go into playing the video, I'll give you a little bit of context, because it's ultimately operations are driven by people. And that's not going to change. We're not going to be replacing all factories suddenly for what they call lights out factory without people. People are going to continue to be central to manufacturing and production operations. And we have not just an opportunity to support them for purposes of productivity, but also a duty to make sure that they're empowered and that we're leveraging all the talent and creativity and capability behind them. So given frontline workers opportunities to access knowledge quicker, to access information quicker, to feedback information quicker, to collaborate more effectively and do their jobs more effectively is really important. And this video is going to show you in a second the possibilities of how technology, what technology is doing today, but also what it can do tomorrow with new technologies like generative AI. So let's just see the video.
This is work.
What's up, Mike?
We're giving eyes and ears to AI. So the world becomes your prompt and your interface. This is work. Working. These are thoughts happening.
Hey, Copilot.
Plans populating.
Copilot, when was this last replaced?
Information gathering. Instructions guiding. Schematics aligning. People connecting. Problem solving.
Copilot?
Hey, Copilot. Copilot.
This is confidence growing. Eyes widening. These are questions.
I just finished Copilot. What's next?
Rotate the engine block 90 degrees.
Questions the way you ask them.
Please get me the detailed view of the optical cable layout.
Never too many questions.
All right. Let's highlight the relay switches.
Go ahead. Keep asking.
It's in position. What's next?
Keep learning.
The hydraulic filter was changed 6 months ago.
Okay, can you pull up the service record?
Copilot, what's the tolerance of this locking ring?
Here is a copy of the last service record. The tolerance is 9,000ths of an inch.
Remind me where this fits into the assembly.
Step 4, align the spindle. The locking ring is highlighted.
This is work getting smarter. This is work working better. This is work working. This is work making sense of the world around you.
Copilot, let Ruth know that I'm finished and close out the work order.
This is AI for the front line.
Particularly inspiring because it shows how can we really augment people and empower people. And one of my favorite phrases in the video is confidence growing. And you can see how people suddenly, we all have a limit to what we know, and there's a lot of information out there that we can leverage, but rather than worrying about what we don't know, is growing our confidence in what we do know and being really able to leverage what we don't know through others and the information that is already there in context. If we go to the next scenario, is around the other side of production, that is less the people side of thing and more the process side of things. And I will spend a huge amount of time talking about this specific example because it's something that perhaps is more mature and people have seen a lot more around automation of factories. But the one point I wanted to make here is actually automation is enabled by data and digital technologies and being able to connect different sources of data in an organization really empowers and enhances the potential of automation, and is something that has happened, for example, in the new facilities at Northvolt. And when you consider the scale of these facilities, making sure that there's seamless access to different types of information and integrated that to enable automation is really important. But the other element is autonomy. And I think if we go to the next example, is a really interesting concept, because usually when we talk about autonomy, there's a little bit of fear around humans being replaced by technology. And I always think that you can always perceive it that way, or you can see the huge opportunity around us as humans having to do less of the most obvious tasks and the most boring tasks and repetitive tasks, and having the time and the empowerment to actually do more interesting things and own the technology, drive the technology, explore more the creative side of things. And this is something that has happened and is in progress at PepsiCo, where there's been a lot of work around the quality aspect of Cheetos, in this case, the manufacturing of Cheetos. And if you can imagine, that type of manufacturing is very, very high volume manufacturing. Being able to detect the quality of each of these Cheetos when you have a ton of them going through the production line very quickly is very, very difficult. And having the ability of using AI to detect those characteristics, to judge those characteristics, and either give the feedback and the information for operators to be able to make decisions quicker, or even when you have a really high level of confidence around the technology, to actually just automate those decisions and leave it to the process and have a self-calibrating process and free people up to do other things, is what's happening in this example, which is really interesting. And if we go to the next stage, I wanted to talk about supply chains. And there are a huge amount of applications in supply chain that are enabled by digital technologies. But one of perhaps the most disruptive applications that has a huge potential from a sustainability perspective is the element of circularity. And data is fundamental to achieving circularity, because to be able to disassemble something that you don't know where it's coming from, to reuse those components, you need to understand where they come from, what are the materials, what's the history of that, do they have faults, do they don't have faults. So understanding the data behind these products to be able to reuse them into the value chain is really important. So I'll show you an example of how within our own company we have used digital technologies to achieve this.
Microsoft's cloud has grown exponentially over the last several years.
The Microsoft cloud is powered by millions of servers at a range of compute, networking, and storage hardware in data centers across more than 60 regions globally.
On average, a server has a lifespan of 5 years. With millions of servers in the Azure fleet, this creates a huge amount of electronic waste. Where is all that metal going to go?
We have to be socially responsible with our e-waste. And it was part of those conversations that really led to this concept of creating a circular center, an area in a Microsoft data center facility where we can reprocess all of this equipment.
Circular centers are transformational, and here's why. We've taken a first-of-kind approach towards designing and implementing circularity into our cloud, aligning our end-of-life dispositioning processes with an integrated plan across the entire supply chain.
This integrated plan ensures that assets are dispositioned to optimize value, security, compliance, and sustainability.
Microsoft has audacious goals. We are committed to be carbon negative, zero waste, water positive, for the entire company by 2030. Sustainability has to be in our DNA from the day we start designing these servers. And it's very important because that determines our carbon emissions, our waste, how much power we consume.
As the hardware arrives on our loading dock for the Circular Center, we have a team of technicians that are standing by. Those technicians then take the hardware and break it down into its individual components so that those components can move to the next phase of its useful life. We leverage an end-to-end planning system aimed at finding the most optimal path for every component that exists across our server fleet.
Now, our goal is to reuse 90% of our cloud computing hardware assets by 2025. Servers might find a second life in schools or job training programs. And the reclaimed memory cards might be used in electronic toys or game systems.
We have successfully demonstrated take-back, buy-back models with our original asset suppliers, resulting in significant sustainability outcomes for emissions reduction and material recovery.
It's been exciting to see how enthused suppliers are to work with us on circular centers and on sustainability in general. Our suppliers want to be part of the solution that we're developing here at Microsoft.
As we've opened our circular centers, we have partnered with our community, developed new jobs, new job categories, and entry-level positions that enable our circular center technicians to move into other jobs across our Microsoft data centers. It's an amazing experience to see something that you drew on a napkin actually come to life. And walking up to the Circular Center, I was overwhelmed. I was overwhelmed by everybody that helped us achieve this vision.
Circular centers are bringing the equivalent of the Industrial Revolution and digital transformation to server decommissioning processes. And I think that's awesome.
It takes a village to do these things. And so when I stood in the Circular Center, it was like, oh my goodness, this is how we can make an impact to make the world better. This is what sustainability means.
In this massive piece of infrastructure, with there's obviously the use of a lot of materials and electronics, just thinking about the fact that you could reuse 90% of it and therefore stop the use of new materials at that rate is quite inspiring, and I think we need to be ambitious around this. So if we go to the last slide, just in terms of call to action, and we click on this, I think I'd like to go back to that, and if we go one step more to that topic around speed and purpose and what we can do about it. And if we go one more, I'll just finish by some of the things that I have learned in my journey around speed and what we can do about it. And I think it's really important to think about not just the digital technology. Of course, the digital technology is the enabler, but it's thinking about overall business transformation and thinking about what that element around how you want to change the organization and how much you can change it to achieve economic benefits or other benefits beyond that. I think that the organizations that have been more able to do this quicker, more effectively, is the ones that are take on a fail-fast approach and really get their hands on with technology, start small, start testing the technology, start taking it to production, and by that not just start unlocking value quickly, but also start learning and driving the change process quickly. There's a very important topic that can be forgotten around who are the organizations and people around us that can help us do this. Thinking about people and skills, what are the new skills that are going to be required and how those skills are developed, and also thinking about not just how can be the business transformed in terms of incremental improvement of what we're doing, but potentially changing the business benefit. And in terms of purpose, I think there's an element around obviously driving operational efficiency, being careful not to, I think we need to be careful around cost cutting, because sometimes it can kind of chop the legs of future growth, but operational efficiency is really important. Leveraging workforce and working with people, empowering people, and making sure that we're being very intentional around how that internal workforce and that hugely valuable talent is transformed within the organization, and looking at sustainability, not just because it's good for the world, but also because it's good for business. You know, when we think about future markets and what the world is going to need, I think there's a big topic around sustainability, not just the environmental aspect, but the people aspect. And sorry that I kind of overran a bit. Richard did tell me, you know, it's of the essence to keep time.
Lina. Yeah, we'll have to tell you off. But thank you very much for ending when you did. Now, there's lots of questions, and I thought what we might do is take them in segments. So the first sort of interesting segment of questions concerned your intro, which was about the increase in productivity in the UK. And David Bogle says UK productivity has been stagnant overall for some time. So the 25% increase for manufacturing is impressive, or perhaps I should say surprising. Do you have any estimates for, well, for the first question he asks is, what's going to happen in the future to that? And my question, I suppose, is what caused the increase? Is it just a very low base? Has it just come up from a very low base?
I think it's an interesting question. I think the first thing is important to clarify what the 25% is. And I want to clarify that it's not 25% productivity, is 25% increase in productivity, and it's also not overall productivity, it's increase in productivity per job. I think that's the first thing, just to put the figure in context, because I think it was quite surprising for me as well when I first saw it. In terms of what caused it, I think unfortunately I don't have a straight answer to that. I'm not an analyst. I think what I have seen is there's been a huge impetus from the manufacturing sector. I've been in the manufacturing sector in the UK for around 16 years. And what I have seen for as long as I have been involved is a very strong sense of community and a very strong sense of self-empowerment and understanding what can we do for ourselves as a sector to drive things. And I see that there's a huge amount of effort inside organizations to do this, despite a lot of, I suppose, systematic challenges for the sector. So even though I can't answer kind of where the improvement coming from, and I think we all as a whole, as a nation, need to do that job of starting to understand that, because it's very easy to report it, but to be able to learn how do we continue that trend, we need to kind of understand the basis. But that's my perspective.
But I mean, I guess because you're quoting it, you think it's genuine. It's not just some peculiar artifact.
Well, it has been, these are figures, the references are in the slides, which might be shared. I'm happy to share the references, but the reference come from, are quoted by government, and they come from OECD analysis. So if I would be surprised if they're wrong figures, we're happy to share the reference of where it is reported. An easy way of finding it is if you look up the latest advanced manufacturing plan published after the announcement from Treasury at the autumn statement from the £4.5 billion investment, you'll see in the introduction of that report those figures.
Yeah, and Phil Williams, I think, makes a point, or is asking a question, which is, I mean, he says it sounds really positive, and I think we all felt, oh gosh, it is a bit more positive than we thought. So do you think it's unhelpful, therefore, for the Governor of the Bank of England to talk about this being the most difficult time for the UK economy he has ever seen? There's a tension between your optimism and what we're hearing from policymakers, isn't there?
I don't think it necessarily means that it's all, and sorry, I don't want to kind of go into too political a topic, because this is more around technology and engineering. But my view is it's very encouraging. I've been also surprised by the figures I've been seeing in the last 6 months. I don't think the figures mean that there are no challenges. I think we still, as a nation, have a lot of challenges to deal with. We need a more consistent approach to a collective approach to what are the areas where we're going to focus, clarity around what are the places where the UK is going to compete. We need a much stronger approach, which has been getting stronger around skills for the whole of the nation, around these specific skills and how we're progressing them, as well as innovation. But I think it's definitely an indication that we're going in the right direction.
And okay, Lina, so to move on to topic perhaps a bit more rather than the background to your talk, I think that a lot of the audience can see the benefits of the of what you're talking about. But at least one person, I think, yeah, Phil Williams asks, what are the threats? You know, so thinking about Copilot was one of your videos, and there was this rather sort of lovely idea that you'd be working on this advanced manufacturing production line, and Copilot would be sort of whispering seductively in your ear, oh, the tolerance on that bull race is out, or don't forget to use the right sort of lubricant. Can you see any threats with deploying, well, it's generative AI, isn't it, Copilot? Can you see any threats with deploying it as it was shown in that video?
Yeah, not necessarily as he was shown in that video. I think we do need to be quite aware of the technology and the different guises of technology, and this is something that we do. And apologies, I'm kind of not promoting Microsoft by any means, even though I come from Microsoft, but I'm talking from my experience. And one of the things that we have to do constantly is raise awareness of when a technology is deployed in a way that is enterprise ready, and the risk involved in different types. So you can, of course, go and access open source models, and you can use those open source models, and they'll be very careful, and there'll be a certain risk associated to it, whether it is because of the reliability of the information that is being used to produce information back to you, or whether it is because of the information you're putting in and where that is potentially going and how it is used. And there's a big difference between that and enterprise ready models from organizations like Microsoft, which is the one that I understand the most, which is why I talk about it, where there's a very different way of deploying these models in a way that is it's not a public model, it's a model that has been trained with public data, but it resides inside your tenant. Your information is not going anywhere. There are guardrails, not just from a security perspective, an IP perspective, but also from a fairness, bias, kind of conflicting information, how much it hallucinates or not, and also the referenceability, for example, and the fact that it's not just giving you an answer, but it's telling you this is where I got the answer from. And it's very important to understand that this is not an automation tool. It is not to replace tasks, and it's very important to understand that it's to work with the human in the loop, and you must always make sure that whatever you're getting either is what you're expecting or is accepted by you, or that you modified, rather than letting the technology completely replace the human loop. And hopefully that kind of answers the question. So there are some risks depending on how you deploy the technology, and I think there needs to be a lot of kind of awareness of organization around how are they going about it.
Lina, I mean, behind every manufacturing chain is an insurer, right? Covering the cost of things when they go wrong. Have you had any dialogue with insurers thinking about the liability that may be increased or reduced if they're using AI?
I haven't personally. I mean, there are certain forms of AI that are quite established. I haven't personally seen scenarios with there's been an insurance company involved, but the confidence of some of these levels, for example, if you think about quality inspection with computer vision, so analyzing an image to detect a defect with artificial intelligence, a lot of that technology is really mature. these days, and it gives you, depending on your scenario, a very high level of confidence. Some of the more generative AI based models, I think, even though I haven't had any conversations with insurance, as I said, I think there needs to be an awareness around what the technology really is, and the fact that the technology is not reasoning, and the brain behind the answers still needs to be the person. What is really helping you do is process a huge amount of information really quickly, so you can get quicker to the answer without taking the human out of the loop. So I think that really kind of changes the risk landscape of this technology.
Okay, a number of questions are sort of craving concrete examples, and you get, which is a good sign, right? You gave some. Nick Bertels is making us aware of Aeralis, which a number of people on the call will know about. It's a modular military jet aircraft. They're a Microsoft customer, and they're a digital manufacturing organization. We've also Chris Atkin from UEA, actually, he's head of engineering at UEA, asks, what's the solution for SMEs who want to get into this sort of space in a relatively affordable way and don't want to have a sort of dialogue with a large co, Microsoft or Siemens, or is there a way they can get started?
Yeah, I think there are two answers to that. From a technology point of view, I think this is AI is a technology that has been embraced not just by large organizations, but also by a huge amount of small organizations. And we work, as well as we work with large organizations, we'll work with quite small organizations that by the nature of technology, sometimes they're also quite new. And they'll do applications that are quite constrained in terms of scope, but very useful, very reliable, and very useful for manufacturers. So in terms of technology, I think the ecosystem is evolving quite quickly, and that's available in the market. I think the part that is sometimes more complicated is the topic of skills, because often these organizations don't necessarily have the digital skills to that extent, and I think it's probably a problem worldwide, but certainly in the UK, I don't think we have enough what we call system integrators, which are usually these organizations who can come and provide those skills on demand. And sometimes the critical mass of those are companies that are usually out of the budget of SMEs. So I think I think it's still possible, and organizations can do it. It might take that little bit more effort and that more work from a skills perspective, but from a national perspective, probably that topic of system integrators is something that is worth thinking about. How can we scale this capability so we can make it available for organizations to go quicker? And one of the things that was announced as part of those 4.5 billion from the government is the additional support to the Made Smarter adoption plan that is focused on specifically SMEs, and provide some of that support around helping them making that technology more accessible and going through the implementation loop. So it's worth looking at that Made Smarter adoption program.
Yeah, it's a very good point, isn't it, Lina? I mean, the cost of machine learning engineers is something else at the moment, isn't it? So the idea that an SME is going to start forking out, $250,000 a year for a machine learning engineer is radical, isn't it? That's not going to happen. So there is a very good case for having packaged units that can be fit together. I guess it's like the early days of robotics. It was same problem, wasn't it?
Exactly, and I think that it's not always the people who are going to develop the algorithms, because some of those are already prepackaged off the shelf from some of these companies that I was mentioning before. But it's more, you can get the algorithm, but how do you, for example, in a quality scenario, how do you work out what are the cameras that you're going to have to use, and who's going to come install the cameras and connect those cameras and the data to your system? Is the integration of the solution, I suppose, as well, that where we need a lot more skills in the UK to make this to accelerate the whole transformation.
Yeah, maybe that's maybe that is the killer application of AI, the AI, deploy AI in manufacturing. Right, ladies and gentlemen, we've come to the end of our time. I'm so sorry. And there were some very good questions that I didn't get a chance to answer. But Lina, we can give you a copy of all of those questions for your delectation, and you're very welcome to sit there tapping answers to them all. Thank you very much for telling us about your thoughts on this matter, and thank you everyone who attended. What else do I need to tell you? I probably need to tell you that there are other lectures in the series that are whizzing up upon us, and if you enjoyed those things, you'll find them all on the YouTube channel. If you want to revisit anything, these are the next lectures in Knowledge Miles. I should also say, if you've enjoyed this lecture and you fancy a sort of longer form version of lectures, then I recommend Gresham College, which has a very impressive and distinguished YouTube channel, as does Zien, actually, who sponsor these lectures and provide much of the expertise. Thank you and goodbye.
Thank you, everyone.